Bismillahirrahmanirrahim and Assalamu alaikum. My name is Ramsha Imran and I am your instructor of compiler construction course. Today's topic is operator precedence parser. In previous lecture, we have talked about construction of recursive descent parser. In today's lecture, we will discuss about what is bottom-up parser, what are the types of bottom-up parser, and how we can generate an operator precedence parser. After this lecture, we will get a clear idea about bottom-up parser, how we can construct a bottom-up parser by using operator precedence parsing algorithm. Okay. If I talk about parsers, so we have learned that we have two types of parser. One is top-down parser and second one is bottom-up parser. In top-down parser, we have talked about we have two types of parser. First one is top-down parser with full backtracking and second one is top-down parser without backtracking. Then we have talked about that bottom-up parser, top-down parser is further subdivided into two subtypes. First one is recursive descent parser and second one is non-recursive descent parser. Now after mid, we discuss about what is non-recursive parser, descent parser and what is recursive descent parser. Now in this lecture, we will talk about what is bottom-up parser, that is also called SR parser. SR means shift reduce parser. Now that bottom-up parser is further subdivided into two main subcategories. First one is operator precedence parser and second one is LR parser. Then LR parser is subdivided into four types: LR0 parser, SLR parser, CLR parser and LR parser. Now, if I talk about in today's lecture, we will talk about what is operator precedence parser. So, first of all, what is bottom-up parser? Bottom-up parsing construct a parser tree for an input string. We construct a parse tree for some input string data tokens, beginning at the leaves and working up towards the root. So basically, what is the difference between top-down parser and bottom-up parser is, in top-down parser, we start constructing a parser from the roots and move towards the leaves. But in bottom-up parser, we will start constructing our parser from the leaves and moves towards the root. So in bottom-up parser, we will construct our parser in opposite manners. To do so, bottom-up parsing tries to find a rightmost derivation of a given string backward. Okay, this is an important point in manners. In top-down parser, we will construct our tree in leftmost derivation. Like in LN grammar, we have taken our string from the left side and we construct our tree. But in bottom-up parser, we start constructing our tree from leaves to node. So we will construct in rightmost derivation. Bottom-up parsing is also called shift-reduce parsing. As I previously told you, bottom-up parsing is also called SR parsing. So SR means shift-reduce parsing. Okay, now start operator precedence parsing. So if we have to learn about what is operator precedence parsing, we have to take an idea what is operator precedence grammar. A grammar G is said to be operator precedence grammar if it possesses following two properties. Okay, a grammar is said to be operator precedence grammar if it has two basic rules or properties. First of all, no production on the right side is null. Okay. First of all, operator precedence grammar doesn't accept your null production. So if we have a grammar in which some non-terminal produce a null string, that grammar is not operator precedence grammar. So operator precedence parser only construct the parser of operator precedence grammar, and operator precedence grammar has some rules, some restrictions. First one restriction is operator precedence grammar does not accept null string. So there should be not any production in your grammar in which you have some null string, any null string. Okay. Second point is there should not be any production rule possessing two adjacent non-terminal at the right hand side. Okay, this is an other important point. If we have a grammar that produce some non-terminal that are adjacent, like if a grammar produce S, capital S, that is a non-terminal, and capital A, these both are non-terminal. Then S produce some string B and A produce a string small b, small a. Okay, so this grammar is not operator precedence grammar basically, because it produces two adjacent non-terminals. So we have to keep these 2 points in mind, that operator precedence grammar cannot generate a null string, and second point is operator precedence grammar does not have two adjacent non-terminals. So grammar in which we want to construct a operator precedence parser, so we have to keep in mind these 2 points. Secondly, what is operator precedence grammar? Basically a grammar that contains some mathematical expression. So mathematical expression are basically a plus b, same as a multiply b, a divided by b, and a subtraction a minus b. Okay. The grammar that contains some mathematical expression is basically operator precedence grammar. And as we know in because in mathematical expression we cannot write a and ab is equal to a multiplied by b. These two terms are not equal to. That's why we cannot write s and a adjacently, because when they replace with their terminal they become b and a. So we cannot say that b and a is equal to b multiplied by a. So there should be a operator, mathematical operator between two terminals. That's why we cannot write these two non-terminals adjacently. So this is the rule of basically this is the rule of operator precedence grammar. Okay. It is a small but important clause of this grammar. An operator precedence parser is a bottom-up parser that interprets an operator precedence grammar. So the parser we construct from operator precedence grammar is operator precedence parser. And one thing is very important in there. Only the operator precedence parser is the only type of parsing technique that can deal with the ambiguous grammar. And let's see how can it deal with the ambiguous grammar. Now these are the examples. Okay, if we have a grammar like this and we have a adjacent non-terminals. Then this grammar is not operator precedence grammar basically. So if we have some ambiguous grammar, as you know, this grammar is ambiguous grammar, but it has some mathematical operations, and every each non-terminal is separated by some mathematical expression. So this is an although this is an ambiguous grammar, but this is an operator precedence grammar, and our operator can handle this grammar and can generate the parser of this grammar. Now, how can we generate the operator precedence parser from this grammar? Okay, to generate the operator precedence parser, we have to generate a operator precedence table like this. Hmm. Like this. We have to generate a operator precedence table. Through this table, we can generate the operator precedence parser. So if we want to generate the operator precedence table, okay, if we want to generate the operator precedence table, we have to follow these rules. First of all, if we have two terminals, okay, this table is generated for only for the terminals. So if we have two terminals and B has higher precedence over A, then we can write it like this. It predicts A like this. It pronounced as B has higher precedence than A. And if we have two terminals that are equal in precedence, then we write equal to sign. And if B has lower precedence, then our braces open mouth is towards A. Like B has higher precedence, B has lower precedence over A. B has lower precedence over A. So our brackets open mouth is toward the higher precedence terminal. In operator precedence parsing, we first define three disjoint precedence relation between every pair of terminals. Okay, we have to write the precedence relation between every pair of terminals, and construct the operator precedence table. So first of all, we have to construct the operator precedence table. Then from that table, we can generate our operator precedence parser. Okay, we have now the main question is which terminal have higher precedence. Okay, for this we will uh, 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 the determination of correct precedence relations between terminals are based on the traditional notation of associativity and precedence of operator. Okay, if we have to find out which one operator have higher precedence, so we will take it as we will take our traditional notations of association for this, in which id has higher precedence than any other symbol. Like in previous lectures, when we talk about ambiguous and unambiguous grammar, we have talked that id always have the highest precedence. So in this grammar, or in every, so id has the highest precedence in this case too. And dollar sign has the lower precedence. These are the some rules we have to remember, that id always have highest precedence, and the dollar sign has should have lower precedence. If two operator having the equal precedence, then we check the associativity of that particular operator. Okay, if we have, for instance, plus and multiplication two operators, okay, then which operator have higher precedence, then we will check sorry, okay, let's suppose we have two operators plus and plus. Okay, So if we have two operators equal precedence, these two operators have equal precedence, then we check the associativity of that particular operator. So we will see that these operators are either left associative or right associative. As we know that plus are uh, left associative, then its precedence should be over left side. Again, if we have two operators of equal precedence, then how can we determine either they are left this operator have highest precedence or this operator have highest precedence? Okay. For this, we will check their associativity. As we know, the multiplication sign have less left associative, so its precedence is towards left side, that it has higher precedence and this one has lower precedence. Okay, these are the some rules that we discussed later. Okay, these are the some rules that we will discuss later. Now we will take an example and try to construct our operator precedence grammar through that rules. Okay. Now let's suppose we have a grammar. Okay. First of all, as we know, this grammar is not operator precedence grammar because it has two non-terminal that are adjacent. Actually, these are three. Okay. So if we have a grammar like this, then how can we construct a operator precedence grammar through this grammar, or how can we convert this grammar into operator precedence grammar? For this, what we will do, we will replace this non-terminal with its production. Okay, we will replace the non-terminal A with its production. Then this grammar will convert it into the operator precedence grammar. See, not every grammar can convert it into the operator precedence grammar. Okay, some of the grammar can convert into the operator precedence grammar. And what are the rules to convert a grammar into operator precedence grammar? For that, we have to replace the non-terminal with its productions. Okay, so we have a non-terminal A. We have a non-terminal A. We can replace it with its terminals or its productions. Okay, so if I replace it, it will become E. First of all, I will replace it with plus, so it will become E plus E. Secondly, again, I will replace it with multiplication, then it will become E multiplied by E. And thirdly, I will replace it with ID. And thirdly, its another production is E produces ID. So with this method, we can convert a non-operator precedence grammar into operator precedence grammar. Let's take another example and convert that grammar into the operator precedence grammar. No, let's suppose we have a production S A S B, and A has production B S H. Okay. Now, if I have to convert first of all, from this scenario, I have identified that this grammar have three adjacent non-terminals. So this grammar is not an operator precedence grammar. So can I convert this grammar into operator precedence grammar? Yes. In next lecture, we will discuss about how we can. In next lecture, we will hopefully discuss about how can we convert our grammar into operator precedence grammar, and what are the rules, what are the scenario, and what are the scenario in which we cannot convert our grammar into the operator precedence grammar. Not every grammar can convert it into the operator precedence grammar. Only some grammars can convert it into the operator precedence grammar. So we will discuss about it later. And now we have to take this scenario and produces our parser. We have to take this graph. Now in this lecture, we will mainly focus about how can we construct operator precedence parser. So if I have to convert this grammar into operator precedence grammar, we have to replace this string, this production over there. Okay. If I will replace, then S, here S, B, S, H, S, and B. Okay. Now if I replace this A with its production, then here we have this grammar, and in this grammar we don't have we have and in this grammar we don't have and in this grammar we don't have any adjacent non-terminal. So this grammar is again the becomes the operator precedence grammar. Okay. Now we will discuss about our previous example. Okay, let's see. This grammar is ambiguous grammar, but we can construct the operator precedence parser of this grammar. Now we will start constructing the parser. Then the parser, let's suppose we have this string id plus id multiplied by id, and we have to construct the parse tree. Okay. Now, if we have to construct the parse tree, we have to generate the operator precedence table. Okay. So this grammar I have already converted that grammar is equivalent to this grammar, and now if I have to generate the tables, I have to now construct the precedence table. For that I have to consider the terminals. So I have four terminals. First one is id, second one is plus, third one is multiplication, and fourth one is dollar sign. Okay. Now in rows I have put all terminals, and in columns and now in rows and columns I have to put all terminals. So in okay, as we have already discussed, we have to define the precedence relation between pair of terminals. So we will define the relation between these pair of terminals. Like id is a pair of terminal. Okay, id and id both are equal, and both are higher precedence, so we don't have to write down their relations. Okay. Secondly, id and plus. For this, okay, if I write it like this, id, and this one is plus. Okay. So I have already told you that id always have highest precedence. So id always have highest precedence. So we will write it like this: id have highest precedence over plus. So I have write it like this because id is written here. So your uh, angular braces mouth should be open towards ID. Now ID and multiplication. So as we know, ID has highest precedence, so it will like this. ID has higher precedence over multiplication. Third time, ID has higher precedence over dollar sign. As we know, dollar sign has always lowest precedence. Now, secondly, about plus and ID. If I write it like this, plus and ID. So ID have should have higher precedence and plus have lower precedence. So it will be like right like this, that plus have lower precedence than ID. So I have write it like this. Plus have lower precedence than ID. Same as next one, plus have uh, plus and plus. Okay, we have plus and plus. So I have already told you, if we have two non-terminals that are of equal precedence, then we will check their associativity. So as we know, plus have the plus is left associative terminal. So we will write it like this, plus and plus, it is left associative, so its left side should be open. Now plus and multiplication. As we know, if we write it plus and multiplication, then multiplication have highest precedence. So it should be like right like this. Multiplication side should be open. So plus and here in plus and multiplication, the multiplication side is open. Now plus and dollar sign. As we know, dollar sign have always have lowest precedence, so the open out should be over plus symbol or terminal. Now plus and ID. In this, ID have always highest precedence, so multiplication over ID, the ID has always highest precedence. So it write like this. Multiplication and plus, as we know, multiplication have higher precedence, so open mouth is towards multiplication. Now multiplication and multiplication both have equal precedence, but these are it is left associative, so this multiplication should be this open mouth should be over left side. Now multiplication and dollar sign. As we know, multiplication have highest precedence. So high multiplication's precedence is higher than dollar sign. So open mouth should be over multiplication. Now if lastly dollar sign and ID have higher precedence, plus have higher precedence, multiplication has higher precedence. As dollar have always have lowest precedence. It's a rule that ID always have highest precedence and dollar sign always have lower precedence. So through these rules we can construct our operator precedence parser. Now through this operator precedence parser we have to construct our operator precedence grammar. We have to construct our operator precedence parser. Okay, now we have a string like this, id plus id multiplied by id. So first of all, I will construct this parser over here. So we will get an idea. Okay, now we have a string like id plus id multiplied by id, and at the end we have a dollar sign. Okay, dollar sign should be always at place. Dollar okay. Now let's we have a string is id plus id multiply with id and dollar sign. Okay, dollar sign shows the end of the string, so it is always put it at the end of your string. And now we have a stack. Okay, now we have some rules like this. We have some insertion rule. That rule card dollar sign symbol at the start and at the end of the input string. Dollar sign should be at the start and at the end of the string. Precedence operator in between every two symbols of the string by referring the design precedence table. Okay, precedence operator should be in between the symbol of the string. Okay, we always put it like this plus a plus b. Sorry, it is small a plus b. So precedence operator should be always in between two uh, terminals. Start scanning the starting from the left until seeing this and put a pointer at its location. Now scan backward the starting from right to the left until seeing this. Everything between these two forms the handle. Okay, only these two operators work. One is for insertion and second is for one is for pop and second is used for push. Replace handle with the head of the respective production. Repeat this step until reaching start symbol. Okay, these are the rules. We will implement it here. Okay. Start of the string should be dollar sign and it will be in the stack. And end of the string dollar sign should be write it here. Okay. First of all, we start with over this and over look at is on id. First input string. Okay. We will read it like dollar sign and id. Dollar sign and id. अब यहाँ पे now here we have two rows. If we have this, we will push into the stack. We will push that symbol into the stack, and we will, if we find this, we will pop from the stack. Okay. We have two rules. If we insert this, we will push. If we find this, we will put into the stack. If we will find this, we will pop out from the stack. Okay. Now, the first symbol is ID and we have dollar sign. This is used for stack, and this one is used for string, input string. Okay. So we will take ID. Yes, there is ID. Then we will see dollar sign. Yes, here there is a dollar sign, and what we will have is and what we will find is this. Okay, if we find this symbol, that dollar sign is lesser than id, then we will push id into the stack. I push that id into the stack, and dollar sign moves towards next point. And our pointer moves towards next point. Now our pointer is over here plus. Okay. Now our current pointer is plus. Now we will see plus, and top of the stack we have id. Okay. Plus and top of the stack is id. This. We have top of the stack id, and here we have plus. Now what I will get is greater than. If I will get this greater than sign, then I will pop that symbol from the stack. So I will pop this symbol from the stack. So id is pop from the stack, and id's parent node is plus. Like we have a I will write our grammar over here. We have a grammar e. So this is our grammar. So I will replace it with its root node, that is e. This one. Okay. Now we again have dollar symbol on the top of the stack. So I will see over here dollar sign, and second our current pointer is over plus, and this one is plus. So what will I get? I get this symbol. So this symbol shows push. Okay. So I will push this current pointer into the stack, and plus is pushed into the added into the stack. Now if plus is added into the stack, so our pointer moves towards next symbol, that is id. Now top of the stack is plus, and current symbol our current symbol is id. So plus and our current symbol is id. If I get this symbol, so I have to push that symbol into the stack. So I will push id into the stack. id into the stack. Okay. Now if I push id into the stack, every time when I push something into the stack, our pointer moves one. Uh, if I push something into the stack, our pointer moves 1 point ahead. Okay, now our pointer, my pointer is over there, multiply. Now, id and multiply. Top of the stack is id, and the pointer is on multiply. I get this, and this means I have to put the top of the stack symbol. So I will pop out this symbol, that is id. Okay, I will pop out this id, and it will be replaced with its root node, that is e. Okay, now I have plus from the top of the stack. Now I will check plus and multiplication. Now this is where plus and this is multiplication. Okay, I have get this symbol. So this symbol mean symbols mean push. So I will push the current node into the stack, that is the multiplication, and now our current node moves 1 point ahead towards next symbol, that is id. Okay, now I will check both of them. This is multiplication and this is id. So top of the stack is multiplication, and current symbol is on id. So if I check multiplication and id. I have to push this current pointer into the stack. So I will push this id into the stack. Okay. Now I have dollar sign id on the top of the stack and id. Sorry, if I push this id into the top of the stack, then my pointer moves 1 point ahead, that is dollar sign. Now I will check top of the stack. I have id and current pointer is on dollar sign. So id and dollar sign, I will get this. So I will pop out this symbol. So I will pop out top of the stack symbol, that is e. I will pop out e. Okay. Now I have multiplication and dollar sign. So multiplication and dollar sign. Again, I get this pop symbol. Okay. If I get this pop symbol, I will pop out this multiplication. So this multiplication should be this one. Okay. This multiplication is basically this symbol. So as we know, if we have plus and multiplication, then multiplication sign will have higher precedence and it will be evaluated first. So this plus e multiplication e. So we have this whole production. We will get this whole production. So I will replace it with e. Okay. Now id is popped out, multiplication is popped out, then this id is popped out. Now we have plus on the top of the stack. Okay, plus and dollar sign. I will see this plus and this one is dollar sign. Okay, now I have to check this symbol shows pop. So I will pop out this plus, and if it will pop out, it will become that e production. Okay, now I have dollar sign on the top of the stack and this dollar sign is on the top of the stack. So it means, so, so yes, I have get this symbol plus. So I will pop out this plus. So when I have pop out this plus, it will become that e. Okay. Now we have all the string popped out from the stack and we have only dollar sign and here is dollar sign. It mean if we get dollar sign at the end of the string and at the end of the stack, it means we successfully construct our parse tree. So here is a full-fledged example through which we can construct our parse tree, and we will talk about how can we construct a parse tree. So we have so through this example we have taken a example where we so in this lecture we take an full-fledged example and construct our parse tree by using operator precedence table and operator precedence grammar. Okay, this is the evaluation. Okay, I have write it in detail here too. How can we construct our parse tree by using this grammar? So these are the rules. At the end, if we get dollar sign on the stack and also in the string, then we will successfully construct our operator precedence grammar. If we don't, then there is an error and we could not construct it successfully. Okay, here is another problem, and I hopefully you will take the there is another grammar, that is operator precedence grammar, and this is a solved. I put it here a solved example of this too, and I hopefully you will solve the and hopefully you will solve it by your own and then compare it with my solution. Hopefully you will solve it by your own firstly, then you can compare it with my solution. And if you have any ambiguity in this lecture, then we will discuss it in Wednesday over live interactive session, which is going to be held on Wednesday, inshallah. So, in today's lecture, we have talked about what is bottom-up parser, what are the types of this bottom-up parser, and then we will discuss about, we have discussed about what is operator precedence grammar, what are the rules of operator precedence grammar, and if some grammar is not operator precedence grammar, then we have to convert in operator precedence grammar. And operator precedence grammar is basically the grammar that have and operator precedence grammar is basically the grammar that contains some mathematical symbols operators in it. And now we have to discuss about then we will discuss about how can we construct a parser by using operator precedence grammar and over then we have discussed how can we construct a operator precedence parser by using operator precedence grammar with the help of stack. Jazakallah for today's lecture. Allah Hafiz.